Hello, this is Andrea Hendricks. The topic of this video is to evaluate composition of trig functions. So before we get into that, let me remind you about some things when we compose a function together with its inverse function. And do you recall that f composed with f inverse of x is equal to x, right? Because a function composed with its inverse, those two things should undo the operation on the number you input, and so you should get back to what you started with. Well, this is certainly true as long as x is in the domain of the inverse function, but it's also in the range of f, right? Because we're going to input one function to get an output, and then that output is going to be the input into the other function. So we have to make sure that those things hold true. F inverse composed with f of x is equal to x, again as long as x is in the domain of f, but also in the range of f inverse. So the way those are going to work with sine, cosine, and tangent and their inverses is like this. That sine composed with sine inverse of x will always be x, as long as x is in the interval from -1 to 1, and let's think about why that's true. Well, we know that the inverse function, its input can only be from -1 to 1. Well, whatever we get for the output of the sine inverse is going to be some angle, but when we take the sine of some angle, we're only going to get an answer between -1 and 1. So as long as x is between -1 and 1, those two things are going to cancel each other out, and your answer is going to be just x. Well, that same thing holds true with cosine. Cosine composed with cosine inverse of x is always x, provided x is between -1 to 1. Tangent composed with tan inverse of x is equal to x as long as x is a real number, and that is because of this. Tan inverse is defined for all real numbers, right? The domain of tan inverse is all reals. Well, then when we take the tangent of some angle, we're going to get all reals as well. So those two things will hold true. Now this is where you get the tricky part. When you have sine inverse, cosine inverse, or tan inverse on the outside, and you're composing that with sine, cosine, and tangent, because sine inverse does not have a range of all reals, right? Or a domain of all reals, rather, I should say. We know that sine x is defined for all reals, okay? But sine inverse, the output of that is not all reals. It is only between -pi/2 and pi/2. So sine inverse of sine x is indeed equal to x as long as that x is in between -pi/2 and pi/2. Cosine inverse of cosine x is equal to x as long as x is between 0 to pi. Tan inverse of tangent of x is equal to x as long as x is between -pi/2 to pi/2. So you've got to think a little bit more when you have the inverse function on the outside. For the inverse function on the outside, the answer is going to be x, or in other words, they're going to cancel each other out as long as x is in the range of those inverse functions. Now, I know I probably made that sound a lot more confusing than it is. Let's go through some examples and let me show you what we mean by that. So if we're taking tangent of arctan of 35, well, those two things cancel each other out provided this number was a real number, right? Because arctan's domain is all reals, and the output of a tangent is all reals. So that's going to be 35. I mean, you can think of it in this way. Arctangent of 35 means what angle has a tangent of 35, and then we're going to take the tangent of that angle, so we should get back 35. Sine of arcsine of -0.1 is equal to -0.1, and that is because this input value is between -1 to 1, right? Arcsine of -0.1 means what angle between -pi/2 and pi/2 has a sine of -0.1. So then we're going to take the sine of that angle, and we should get -0.1. Arc cosine of 7 pi/2. Now this is where we're going to get into some problems, because notice that we have the cosine inverse on the outside. And because arc cosine has what? Its output values can only be between 0 and pi. And 7 pi over 2 is outside of that, but that does not mean we cannot do this problem. What you have to do here is another step. We have to figure out what the cosine of 7 pi over 2 is. Right? The domain of cosine is all real, so we can figure out what cosine of 7 pi over 2 is. And if you need to, use your unit circle. Where does 7 pi over 2 lie? Give you a minute to think about that. So you can think about 7 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 makes a full rotation around the circle. 5 pi over 2 is up at the 90-degree mark. 6 pi over 2 is at the pi mark, right? That's a coterminal angle with pi. So 7 pi over 2 is down at here. Okay? And so what is cosine of 7 pi over 2? Cosine of 7 pi over 2 is 0. So this is really saying what is the arc cosine of 0? So arc cosine of 0 means what? It means to tell me an angle between 0 and pi whose cosine is 0. And that angle is pi over 2. So you can see here that arc cosine of 7 pi over 2 is pi over 2. In other words, those two things didn't just cancel out to give me whatever was inside of the function, because the 7 pi over 2 is outside of the range of the inverse cosine function. So these are going to require a little bit more thought. What about sine inverse of sine of 7 pi over 4? Well, for that to be x, in other words, for them to cancel each other out, that input has to be in the range of the inverse sine. And the range of the inverse sine is between negative pi over 2 and pi over 2. So this does not fall within those criteria. So we've got to think about, well, what is the sine of 7 pi over 4? Well, if you think about where does 7 pi over 4 lie, right, we have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So here is 7 pi over 4. So the sine of 7 pi over 4, right, that point is the square root of 2 over 2, negative square root of 2 over 2. So we're really looking at the sine inverse of the negative square root of 2 over 2. So now we need to think about what is an angle between negative pi over 2 and pi over 2 that has a sine of negative square root of 2 over 2. And that is going to be a negative pi over 4. What about cosine inverse of cosine of 3 pi over 2? Well, this is kind of similar to number 3 there, because cosine of 3 pi over 2, notice that 3 pi over 2 is what? It's not in the range of the inverse cosine, but we do know what the cosine of 3 pi over 2 is. Cosine of 3 pi over 2 is 0. And so what is the cosine inverse of 0? Yeah, it's going to be exactly what we just talked about. It is pi over 2. What we talked about in number 3. So let me take a step back before I finish these. Let me talk about when those things are going to cancel each other out. Like if, for instance, I had cosine inverse of cosine of pi over 2. Well, since that angle is between 0 and pi, which is the range of the inverse function, those are going to cancel each other out to just give you pi over 2. If I wanted to do sine inverse of sine of negative pi over 3, that's going to be negative pi over 3 because the angle here is between the negative pi over 2 and the pi over 2. So if the angle inside that cosine or sine function is in the range of the inverse trig function, then those are going to cancel each other out just to give you the angle that you started with. Okay? But if it's not, that's when you've got to do some thinking about that. Now you can combine inverse with tangent and so on. So let's think about this now. If I want to find the arc cosine or inverse cosine function of tangent of 3 pi over 4, I'm just going to have to work this in steps. I need to figure out first what is the tangent of 3 pi over 4. Well, the tangent of 3 pi over 4, think about on your unit circle, where's 3 pi over 4? That's in quadrant 2, right? And so when we divide the sine and cosine values, we're going to get a negative 1. So now we need to think about what is the arc cosine of negative 1. In other words, what angle between 0 and pi has a cosine of negative 1? And that is, pi. What about cosine of arc tangent of negative 1? So going in a little bit of the reverse direction there. So we're looking at thinking about arc tangent of negative 1. Arc tangent of negative 1 means to tell me what angle between negative pi over 2 and pi over 2 has a tangent of negative 1. So it's got to be an angle that's in the fourth quadrant for it to be negative, and that would be negative pi over 4. So now I need to think about what is the cosine of negative pi over 4, and that is the square root of 2 over 2. What about sine of arc tangent of negative 1? So very similar, that is just going to be sine of negative pi over 4. And the sine of negative pi over 4 is negative square root of 2 over 2. Number 9 is the arc cosine of sine of negative pi over 6. So on your unit circle you can think about what is the sine of negative pi over 6. You can certainly use your calculator to come up with all of these answers, but again I want you to think about some of these things. Arc cosine, well, what is sine of negative pi over 6? That would be a negative 1/2, right? You can think about reference angles or whatever you need to do to get that value. Now the arc cosine of negative 1/2 means tell me an angle between 0 and pi such that the cosine of that angle is negative 1/2. So an angle between 0 and pi whose cosine is negative 1/2 is 2 pi over 3. Now, number 10 here I want to show you is a little bit different. It's to find the exact value of the sine of the arc tangent of 4/3. So the way we're going to do this is kind of go back to constructing the right triangles. What I want to do is let u equal the arc tangent of 4/3. And if u is equal to the arc tangent of 4/3, that means that tangent of u has to be 4/3. Well, remember that arc tangent is an angle between negative pi over 2 and pi over 2. So for tangent to be positive, it has to be a first quadrant angle. So we can think about constructing kind of a first quadrant angle where we have our angle u. Remember what tangent of u is in terms of right triangles. Tangent is what? If you think about some old hen caught another hen taking oats away, it is opposite over adjacent, which would be written in this manner. to find the sine of this, right, because this is really meaning now to find the sine of the angle u. If I replace arctan of 4/3 with u. Well, sine is found by doing opposite over hypotenuse, so I need to figure out what the hypotenuse is. To figure out the hypotenuse, we have to do the Pythagorean theorem, right? We know 3 squared plus 4 squared is going to equal our radius squared, or our hypotenuse. So that's 9 plus 16, or 25, is equal to r squared. So therefore r is 5. So we know this value to be 5. So now we can find the sine of u to be the opposite over hypotenuse, which would be 4 over 5. Okay. So a lot of examples here. If you have any questions or get bogged down with that, please don't hesitate to contact me. Thanks.